Okay, so in this video we're going to derive spherical coordinates. Spherical coordinates are like polar coordinates, but in 3D space. So instead of just having our x and y, we now have x, y, and z. Okay, so we want to express x, y, and z in terms of rho, phi, and theta, where rho is the distance to the origin, phi is this angle from the positive x-axis, and, theta is this angle from the positive x-axis, and phi is this angle from the positive z-axis. So here we go. I drew out a bunch of right triangles from our diagram right here, and we can go ahead and take a look at this. So this is our normal standard basic polar coordinates, right? So we know what x and y are in terms of r and theta. So this is going to be our cosine theta. We can just use our SOHCAHTOA, sine theta, right? Pretty easy, right? Now this diagram is a bit new. It's purely in our z-axis, and it's at a slight angle right here, okay? So let's see. We have this angle phi right here, and we have this z-axis, and we have this line with length z. These are parallel lines, so we can go ahead and use some geometry, and so that this angle is phi. Now we can just use our SOHCAHTOA. So let's see. We have that we can find z in terms of rho and phi. So let's see. It'll be cosine phi. That'll be z over rho. So it'll be rho cosine phi. Okay. Now let's find r. R is going to be sine rho sine phi just by SOHCAHTOA. Okay, so now we can express everything in terms of rho, phi, and theta. So we have x, which is r, which is rho sine phi cosine theta. Then we have y, which is rho sine phi sine theta. Then you have z,